Stress, we know, is the resistance force offered by a body s- offered by a offered by a body against deformation per unit area. It is the resistance force offered by a body against deformation. So against deformation, if deformation per unit area, against per unit area. So stress has a symbol sigma. Sigma is equal to the force, resistance force. The symbol is FRP divided by A. Okay. Stress is the resistance force offered by a body against deformation per unit area. Stress is equal to force per unit area. The resistance force offered by a body against deformation per unit area. It has symbols in MKS system as well as SI system. So what is MKS? It is meter, kilogram, second. So here we are having force. Force is the force or the load. Simply say, you can also say load. So the load, it is offering resistance force against a deformation, so something is acting on it, so that is a load, the force. So here in MK system, for the unit we have kg force. Per area it is meter square. In SI system means international system of units. International system of units. SI, for force we are having SI unit as Newton and meter square, or you can also change it into Newton into centimeters as 100 into 100 centimeters square. That means 1 meter equal to 100 into 100. This Newton by Newton 10 power 4 centimeters square. Or you can decrease the value, you can cut down the value as Newton 10 power 4 centimeter. 1 centimeter equal to 10 millimeters into 10 millimeters. Then it will come up to Newton divided by 10 power 6 mm square. So in SI system, its units are 10 power minus 6 Newton per mm square. In MKS, kg force, 1 kg force, 1 kilogram of force acting per unit area, or something like that. You can also some x kilogram of force acting per unit area. So what is the then stress? Now up to what I have done. Stress is the resistance force offered by a body against deformation per unit area. Stress is also symbol is sigma equal to force per unit area. You can also have this F or this P, or sometimes this entire resistance force is Y because of some load. Then we have two types of systems, MKS and SI. In MKS system we have meter kg second, so kilogram force per meter square. In SI system, Newton per meter square. It is international system of units. For force we are having Newton as its symbol, in SI system. So here if you brought down SI system, Newton per meter square you can write, or Newton per 10 power 4 Newton divided by 10 power 4 centimeter square, or simply 10 power minus 6 into Newton per mm square. These are stress. If you give stress, then automatically there is a one more thing that will come into action: strain. Strain is the amount of change in length. Change in length by original length. So now change in length. So change in some x. Strain means change in x by given and something. Here we are having no units, as both the units are in the same matrix, same matrix. So to understand more conveniently, we are drawing a drawing here. One piece of wood is there. Here we are pulling apart, and the load is applied is P. Then at some point x, the resistance force offered by a body is also P at some x point, due to which it tries to elongate by some delta L dl. Delta L, this length is, suppose say L, it is delta L times this is increasing. So here stress is that force per unit area. Strain we have a symbol epsilon into delta L by L. Here we are having tensile stress. Tensile stress means pulling apart. If we have compressive stress, the same xx, then the same resistance is offered in the reverse direction, which will shrunk it by delta L length. Same, then again also same formulas will be applicable. Tomorrow we will going to learn about shear stress.